Hi, in continuation with some tricky and hard cbse questions, we have another question on maximum minima. Find the maximum area of an isosceles triangle inscribed in an ellipse x square by a square plus y square by b square is equal to 1 with its vertex at one end of the major axis. So, our usual assumptions are a is always larger than that of b. So, our ellipse is going to be having center at the origin, endpoints of the major axis as a comma 0 minus a comma 0. The triangle is isosceles in nature with one vertex as the one endpoint of the major axis. Let me take a as one vertex. So because of symmetry, the triangle is isosceles. The ellipse is symmetric with respect to x-axis, symmetric with respect to y-axis. So if I take AB is equal to AC, AB and AC should be equal. BC will become a vertical line. Now you can ask me, should we take BC here or should we take a BC here? It doesn't really matter. The value will get adjusted accordingly. Now I have taken B and C to lie in the second quadrant and third quadrant respectively. BC will be a vertical line. Let me assume this point as some minus k comma 0 because I have taken it on the negative x-axis. So my B also will have the x coordinate as minus k comma something. C also will have the x coordinate as minus k comma something. But B and C lie on the ellipse. So if I put x is equal to minus k in the ellipse, x square by a square plus y square by b square is equal to 1, we get k square by a square plus y square by b square is equal to 1. So I get y square by b square is 1 minus k square by a square, which is a square minus k square divided by a square. So y is equal to plus or minus b by a into root of a square minus k square. So this point is going to have my b. B is going to have the coordinates as minus k comma b by a into root of a square minus k square. My c is going to have the vertex as minus k comma minus b by a into root of a square minus k square. The area of the triangle, let me call it as A, is going to be half into the base is BC. The length of BC is this portion is b by a into root of a square minus k square. This length is also b by a into root of a square minus k square. So base is 2 times b by a into root of a square minus k square into height. This is the height of the isosceles triangle. So this length is equal to a units. This length is going to be k units. So the total height is going to be a plus k. So that area is going to be a function of k. I'll cancel a 2. I'm left with b by a into root of a square minus k square into a plus k. Now we need to differentiate this area to maximize the area. Let us write this function area as a function of k. This is b by a into root of a square minus k square into a plus k. Let us differentiate with respect to k. So keep b by a outside. Let us use product rule. Root of a square minus k square into derivative of a plus k is 1 plus a plus k into derivative of root of a square minus k square is 1 by 2 root a square minus k square into minus 2k. Let us try to simplify this. B by a, we can cancel a 2. We can take an LCM as root of a square minus k square. So this becomes a square minus k square and then minus ak minus k square. And first derivative is equal to 0 for maximum minima. So this gives you a square minus ak minus 2k square is equal to 0. We need the value of k. So let me multiply throughout by a minus sign. So it becomes 2k square plus ak minus a square is equal to 0. This can be factorized as 2k k. So I think I'll put a plus a here and a minus a here so that I'll get a 2ak minus ak minus a square. So that gives me two values for k. K is equal to a by 2 or k is equal to minus a. If k is equal to uh, minus a, that means if k is equal to minus a, this point minus k will become a. If k is equal to minus a, this point will become a comma 0. That means this point coincides with this point. The point where BC meets the x-axis coincides with A. That means there is no triangle at all, or the triangle will have a minimum area. The area of the triangle, minimum area of the triangle will become 0. So we will reject k is equal to minus A. So it should be k is equal to A by 2, which is giving the maximum area. I am not proceeding with the second derivative, so I'll just leave the second derivative test to you. So I'm getting k is equal to A by 2. Now the question is, what is the maximum area? So the maximum area is going to be b by a into root of a square minus k square into a plus k. If I substitute k is equal to a by 2, it becomes b by a root of a square minus a square by 4 into a plus a by 2. So a square minus a square by 4 is a 3a square by 4, which is b by a into root of 3a square by 4 is root 3a divided by 2 into a plus a by 2 is 3a divided by 2. So I think I can cancel a in the numerator and denominator. So the area is going to be 3 root 3 AB divided by 4 is going to be the maximum area of the isosceles triangle, which is inscribed in the standard ellipse x square by a square plus y square by b square is equal to 1. What if you take BC on this side? It doesn't really matter. You will take this point as k comma 0. The height will become a minus k. Still the value of k will get adjusted mutually. It doesn't really matter. So that is also another tricky question under maxima minima.